when looking at the spring math topic of algebraic proportions, one thing that will always work is cross multiplication. So when we're doing that, some key terms used are cross multiplying, and then we'll have to divide as the inverse operation. So when we're looking at that method, cross multiplying means multiplying diagonally. So we're going to take 2 times 63 is 126, and then we're going to multiply 6 times x and get 6x. So that means they're equal to each other, all right? And then to get x by itself, this is where the division comes into play. We divide both sides by 6, and 126 divided by 6 is 21. So x would be 21. All right, like I said, cross multiplication will always work. So 2 times x is 2x, and then 21 times 6 is 126. We divide both sides by 2, and 126 divided by 2 is 63. But there's another method that we can look at for this particular problem, and it doesn't always work, which is why cross multiplication, like this is what you have to know and be able to use. But we can see when we have fractions that are equal to each other, the ratio between the numerator and the denominator is always going to be the same. So when I look at this and I see, oh, I can multiply 2 times 3 to get 6, that has to be the same ratio in that other fraction. So 21 times 3 is 63. Once again, we can use cross multiplication. This will always work over here. So 7 times 98, that's a tough one to do in my head, so I'm going to come off to the side. 8 times 7 is 56. Carry the 5. 7 times 9 is 63. Plus the 5 gives us 68. So we'll have 686 equals 2x. And then dividing by 2 is just cutting this in half. So 686 in half. Half of 6 is 3. Half of 8 is 4. Half of 6 is 3 again. So we get x equals 343. But as in this one, where we saw the common ratio, we had to multiply the numerator by 3 to get the denominator. It works horizontally as well. So when I'm looking at, there is a number I can multiply 2 by to get 49, or to get 98, and that's 49. So if I have to multiply 2 by 49, I can do the same thing to the numerator to get an equivalent fraction. So we can do 49 times 7, which once again, tough to do in our heads. We know what the answer is going to be, but 9 times 7 is 63, carry the 6. 7 times 4 is 28, plus 6 is 343. So we get the same answer with just a different method. Continuing on, we can utilize that trick here if you know your times tables. That 7 times 12 is 84. So 3 times 12 is 36. Same thing, 8 times 12 is 96, so 5 times 12 is 60. It works going the other direction, obviously. 2 times 42 would give me 84. And once again, I could take 7 times 42, which can't do in my head, that's okay. 2 times 7 is 14, carry the 1. 7 times 4 is 28, so I get 294 for x. Here, I can't do 3 times something to get 68. That's not a nice number. But I do notice that I can do 3 times 2 to get 6. So 68. I can multiply that by 2. 68 times 2 is 136. Here, the numerator and denominator are the same. These are the free questions. All right, numerator and denominator are the same. That's got to be 5. I can double 6 to get 12. So double 8. I would have 16, but once again, cross multiplication would work as well. So just one more time. 8 times 12 is 96. 6 times x is 6x, so I can divide both sides by 6, and x ends up being 16. And if you didn't know that 6 goes into 96 6 times, you can still do the division. 6 goes into 9 once. 1 times 6 is 6. We bring down the 6 because 9 minus 6 was 3. So now we got how many times is 6 going to 36? And that's 16. So that's where that comes from. So repeating myself again, cross multiplication will always work if you don't see the relationship between either the numerator and the denominator or the denominators and numerators. So cross multiplication works, but there are other tricks that can maybe make it go a little faster.